So 9. 51 and 9.4?
Yeah, page 597.
Okay. Oh, yeah. You gotta love it when it starts off, 2 cars leave Denver. Oh, and I have a question here, too, I gotta remember. So 2 cars leave Denver, traveling in opposite directions. One car travels at a speed of 75 and the other at 88 kilometers an hour. How many hours will they be? 489 kilometers apart. That one, right? So a really good first step would be to give yourself a little sketch of what's going on. So they both start in Denver, but they travel in opposite directions, right? And the question is, how long until they're 489? So this distance here, this little piece here, is the distance that the first car went. So this is the distance first car, and this is the distance that the second car went. So the overall connection here is that these 2 distances have to add to be 489. Cool. All right. So eventually that's going to be where my equation comes from. Let's build our little chart, dude. And we'll call this one east going and west going. How's that sound? Doesn't matter. Just one or the other. So the first one car travels at a speed of 75 kilometers an hour. So 75 kilometers an hour. And the other one is 88. And how many hours will they be 489 kilometers apart? Now, however long this guy's been traveling, how does it relate to how long this guy's been traveling? How do they relate to each other?
It's the same.
It's the same. They both started off. 2 cars leave Denver. See you later. Bye. And so, however long this one's been traveling, how long has this one been traveling?
Same.
I love it. So, how long he's been traveling? Good. So, how long has he been traveling? No, come on, what did we just say? X. So, remember, you can only call them the same variable when they are the same, right? And in this case, they are the same, aren't they? If we start and we go, and then when it's 489 kilometers apart, we blow up because it's a strange sequel to speed or something, right? That means we've been traveling for the exact same amount of time. How are we doing so far? So that's the first kind of hurdle we get over is, I don't need 2 variables here for any reason. They are the same, so I use the same variable for each. Which means the distance for this guy is what?
75.
Together they're 49. Neither one alone went 489, right? Together they went a total of 489. Rate times time is distance, so... And these 2 distances have to add to be that. There you go. There's your equation. I knew going in that's going to be my equation. I just had to figure out what the 2 distances were. In Mathfish, I don't know what they are in English. In Mathfish, they're 75x and 88x, right? So I know that whatever he went, whatever the other guy went, must be totaling 489. How are we doing? Yes, sir.
Was the speed different than the distance? I thought it was miles per hour in kilometers, or miles in kilometers.
No, this one was everything's kilometers.
Was everything kilometers?
Yeah.
Okay.
Yeah, thankfully. Well, you're right. If you got to make sure the units match up. If they don't match up, you have to force them to match up.
Okay,
and that's not a pretty conversion, really.
It didn't seem like it.
See, when you put it that way, you make it seem so easy.
I know. It's setting it up is the hardest part.
Exactly. But if you didn't know about this, just start doing this. The big thing on that problem was the fact that they're both traveling at the same time. They don't say it, but they leave Denver, and how long until they're this far apart? Inherent in that is they've been traveling for the same amount of time, which mathematically means I can use the same letter for each because they are equal. Okay, cool.
So we only use one equation?
Yeah, we only ever use one equation. Whenever we've had any of these, we've only had one equation that comes out. Unless you use, two variables here. You don't have to. But I only have one variable, so I only need one equation, right? Cool. Okay. Anything else from homework? Yes?
Section 9.6, page 616, number 5.
Okay. So you hold on to that. We haven't officially gotten in there, I don't think.
Okay.
Yeah. I've been talking a little bit about factoring, but we haven't officially gotten into section 9.6. I don't think. Pretty sure last time we ended up in 9.5. Yeah.
Yeah, I have from 9.4 a question. So
Okay.
That's page number 597. Question number 42.
42?
Yeah.
That's a good point. Sorry, I was just looking back at number 51, the one we just did, and they stuck it into the systems of equations and two variables section. I don't know why. That was kind of mean.
50 what?
51, this one.
Yeah,
So I don't
that's
blame you for having trouble, because I didn't even realize they put it in that section. That was mean. That was
that's
mean.
why I thought you had
Now you could do this.
Oh, there's.
X, Y, y, and then your second equation is x equals y. But why? Yeah. So that was the book's fault. They made it seem like you had to use two variables, and then you're freaking out. I can understand. No, you don't need two variables because they're the same amount of time. Cool. So that was mean of the book. 42. They define this in the problem. Complementary angles do what?
add up to 90.
Add to 90. What kind of angles add to 180?
45.
Supplementary. I love it. So if they have supplementary angles, they have to add to 180. Two angles are complementary. So what can I write from that?
A plus B is X, Y
Okay, x
plus Y
plus y.
equals 90.
Great. All right. So two angles are complementary. You're calling the angles x and y. First angle, second angle. Is that cool? Okay. God, this semester, all of my classes would kill me in poker. I swear to God, you're all. I can't.
Is it if you give instead of X and Y and R?
You can use A and B.
Okay.
You can use smiley face and box. You can use, I don't care. Any symbols that represent the value.
Okay.
So we normally start with X and Y. Their difference is 12 degrees. How do you write that?
Is that X minus Y?
And then what's a really nice way to solve that system?
Yes.
Elimination, because if you add them now, the Y's go. There you go.
Yeah, but can you try it?
Okay.
Yeah.
2x. So x is 51. So the first angle is 51 degrees. And what's the second angle going to be?
Minus.
So I can use either one of these equations. So if I use that one, 51 plus y equals 90. Y equals 39. Are they 12 apart? Yes. I use that one to get the answer, use the other one to check it. Of course this one works. That's where I got it from. Use the other one and go, okay, it also does that. Good. So it looks like it's right. Yeah.
Can you read the question to that problem again?
Two angles are complementary. The difference in the angles is 12 degrees. Find the angles. Good. And so they define up here complementary angles add up to be 90. Cool. Okay. You guys make me tired. Everywhere I look, somebody's yawning. Jeez. It's late in the day and it's math, Jeff. What do you want? All right. Anything else from homework? Except for you. We'll get to your question.
I have one question, but it's from 9.6.
Okay, we'll get into that. What's up?
You have the third for that.
Oh, yeah, thank you. I keep forgetting that. Let me hook this up before I forget. My poor little phone died earlier. A little battery pack. Why are you so loose? Okay. Poor little dude. Man, this is exciting. Alright. Stay. Alright, so I got a question here. It's from the online homework. So they tell me the base of a triangle section 9. Actually, well, I'll tell you what. I just noticed this is from section 9.6. So don't let me forget here in a second. I want to first talk about factoring, and then we'll do this problem.
Oh, we have it. Oh, okay.
Yeah.
So that's right.
All right. So I put that factoring worksheet. Oh, I gave you guys copies of it, didn't I? Good. All right. So I'm going to go pretty quickly through factoring methods. You must slow me down if you need to. If I'm going too fast through something. Just got to go through this one at a time here. How would I factor something like this here? What method would I use to factor this?
The big X.
Nope.
Take out,
One small one.
Oh,
Yes.
GCS?
GCF. Sweet. Two reasons why you should do that. One is because you always try first. You always try that first. And secondly, that's the only damn thing I do. Maybe you could say it's a trinomial, but it doesn't look anything like something I could factor as a trinomial, right? That would be like x squared minus 4x plus 9 or something. I can try to factor that. But this is not in that form. It's loaded with x's and y's and stuff. So it's just screaming for GCF. So the number that can come out, 2. And I can take 1x and 1y. All right, so I call you the fair tax person. You're not going to take 2 y's out because he can give 2, but he can only give 1, right? It's not fair. So what's left here? 2x, good. 2x's, you took 1, 1y, you took it. Minus. Good. 1x, you took it. 3 y's, you took 1, so you got 2 left. Beautiful. Don't stop there. That's no good. Because now if I multiply this out, I don't get all this. This divided by itself is 1. So you got that 1 placeholder, dude, right? Cool. So that's GCF. How are we doing so far? Okay, so let's go to the next level of GCF. I just gave away the method you're going to use on this problem. Let's see, what do you got, Chuck? The instructions on this would say factor, and your first instinct might be to distribute, but that's crazy. There's very few times you multiply when the instructions say factor, because those are two opposite operations.
Would you take out the x?
Beautiful. Take out the x minus 1. They both have an x minus 1, so it can come out. You with me? So this is where you first start to realize x minus 1 is one thing. So this is the same problem really as this. Those are the exact same problem. Except this is a little bit easier to tell what to do. What would you do here? Take out an a. Whatever this is, I'm going to take it out because it's got both of them. So there. Take out an x minus 1. The next big mistake I see is people do this. What did I do wrong?
It's not square.
It's not square. It's not 2 of them. There's one of them that I gave to this guy and I gave to this guy. There's not 2 x minus 1s. Right? And that, of course, is where some of you guys worry about my mental condition, but there's not 2 x minus 1s. There's one that was given to both of them. How are we doing so far? This should all be old news. But if you have a question, feel free to ask, because it might be a while for some of us. Okay? So, of course, that comes from grouping, right? Grouping is where you expect to get here. So if I had something like this here, oh, I guess it should work. That would be good, Jeff. Okay. Let's see if Jeff did that right. So I gave this away too. What method to use here? I did just say it. Grouping. So there's 4 or more terms I'm going to group. All right? And I highly suggest you do not draw in parentheses, because when you do that, this minus sign is really weird to keep track of. So I want to group it. I want these two and these two in groups. What comes down to these two? A, B. Good. So considering that I want this thing to be the same as this, what must I take out of here? Y squared. I disagree in one way.
Y.
No, you got to take y squared out.
Y.
Minus. Yeah, good. I got to take a negative out because this first thing is supposed to be positive, isn't it? I need this and this to be the same, or I can't finish it. If they're not the same, either I made a mistake or it's not factoral. You guys with me? Because I always get somebody. Yes.
I was going to say, is it because you bring that negative down?
In a way, but I got to take a negative out of here, so that this first term is positive, like that one is. These two have got to be the same. This first term is currently negative. I want that to be positive in there, so I've got to take a negative out. And you're right, most of the time, if this middle sign's negative, I'm going to take a negative out, most of the time. Right, so it really is taking that negative out. That's there. So then I get this. What mistake did I make here?
You added it.
Yeah, you added it.
It's not much.
Yeah, what's it supposed to be?
Negative.
Yeah, this divided by a negative is positive. Positive divided by negative is minus. But I love it when somebody writes this and then they're able to do the next step. That's neat. The next step needs these two to be the same. If they're not the same, the problem is telling you you made a mistake. That kicks ass. Math does not always do that for me. It doesn't say, hey, you made a mistake. Oh, okay. Cool. So then what's the last step there?
Yes.
Okay, yeah, see? Okay. Cool. Yes. And I can't go further here because they're not both square stuff, so I gotta stop there. Cool. Okay?
So it has to be A minus y squared.
Yeah. AB minus y squared. And take an a minus 4 out. Cool. Okay, how are we doing so far? This should all be familiar. Okay, so the next level would be trinomial stuff. There's 2 different kinds of trinomial stuff. There's the easier kind. It doesn't have to mean that it's easy. Ooh, I like it. That's impossible. There you go. So let me show you a little trick. Not a trick, really. Who remembers what 2 things have to happen to find the right numbers for this?
Add up and multiply.
Add up to... No, try again. They have to add to be negative 2 because the middle term comes from O and I FOIL adding together, right? And the last term comes from the last 2 multiplied together. So I need 2 numbers that, because I know x squared is going to be x and x. The whole point, the whole problem is what the hell numbers go there to make these work. So they have to multiply to be that and add to be that. Shit, how many factors of 440 are there? A lot. So I suggest this. You just need to really pay attention. I don't know why people don't teach this way. You just need two numbers that do both of those things. They multiply by 440 and they add to be 2, right? And the negatives are in there. So why start with 440? What two numbers add to be negative 2? No. Now think about it. They have to be what kind of numbers?
Negative.
Different signs. Not two negatives, because that would make a positive when you multiply, right? They got to be two negatives. So let me get it started. Oh,
Positive and negative.
good. So let me get it started. 10 and 8. If the 10 is negative, doesn't that make negative 2?
Yeah.
But of course they multiply to be negative 80. Way too small, right? So take kind of a big step up. Negative 20 and 18. We're getting closer, right? Negative 20 times 18 is negative. Twice 18 is? So it's 360. Just that tack the 0 on, right? You guys with me?
Yeah.
Getting close to 440, right? So maybe... And say again, 26 and 24? Well, that multiplies to be what? 520. Yeah. Who? 6?
24?
20? Oh, that is too much. Yeah. 22 and 20. There you go. And you can be smart about it too. You know it's supposed to end in 0. There's a lot of little things you could do to make this quicker. You're not supposed to end in 0, so it almost requires that one of them end in a 0, right? You guys got it? Now, you can always take 440 and start factoring it if you like that way better. But there's not a damn thing in hell that says you have to get the two numbers to do this first and then make them do this. No, I'm going to make them do this first and then see which ones make this happen too. It's a lot easier to make that list. So what does this tell me I can do here?
Minus 22. Add 20.
Big ass. There you go. Well, when we teach it, so often teachers focus so much on that 440. There's no reason for that. You just need both of them to work. Who cares which one works first? So what about this problem? What's different about this dude here? Yeah, there's a number out front. That sucks. When the first number is 1, that's easy.
You can divide it.
Do what?
You can divide it.
Yeah, that would suck because then I get all these fractions running around, right? Good. So one method you could use here is what I call the Surefire Method, because that's what it was called when I was taught it. There's also a method called Texas Slide, so don't talk to me about weird names. So what you have to do is take 4 into account. And you know, I really want this to make sense. How many of you guys have ever done what I'm about to do? Does that sound familiar at all? 5 people. Okay. How do you guys do that problem? Well, there you go. That's what I'm about. But you're the one that held your hand up. Who did it a different way? How do you do it?
You have to put like 2 empty spaces in between the equation, and it's like...
Yes, good. So you want to break this middle term up. Is that what you're talking about?
Yeah.
You want to break that middle term up. So then I have 1, 2, 3, 4 terms, and 4 terms is easy because I just group. And grouping is easy. Relatively easy. Okay. So, but I want it to make sense why we do this weird 4 times negative 6 is negative 24. I want that to make sense. So, stay with me. What if I had 4x plus 3 times x minus 5? Now, I know that's not the answer there, but it's just an example of going backwards from what I'm doing now, right? Factoring would be the opposite of what I'm about to do. But help me out. What do I get if I FOIL this out? 4 squared? Now watch, this is kind of cool. That last term is these two multiplied, right? That middle term, is that these two added? Negative 5 plus 3 is negative 17. Do you see? So that, and why did that happen? Because this is not 5 and 3 anymore, is it? It's 20 and 3. Stay with me now, because see, that this 4 messed my middle terms up, didn't it? It got up in the business. It got in there and screwed this up.
What is that?
Where is it?
Where your finger just was. What does that say? After, yeah, what is that?
That's a plus 3x. Okay. Now watch. This is kind of cool. You ready? What's 4 times 15? 60. Negative 60, right? What's 20 times 3? Holy shit. So if I can find factors of this that add to the middle term, that's how I'm going to break it up. That's exactly why that works that way. That's why I must take this first number into account, because it messes my middle terms up. So the first thing I do here is 4 times negative 6 is negative 24. What are factors of 24 that make negative 5? 8 and 3, which one's negative?
8.
The bigger one, cool. Okay, how are you guys doing? You with me? Yeah. All right. That's awesome. So then you get minus 8x plus 3x. Don't forget your x, right? These are numbers, but there's coefficients on the x. The middle terms actually have to add to be what was there. It's very important. And then we said, what can we do? Group it. Now, does anybody find these two numbers and then divide by something and do weird shit? Anybody ever get taught that way? All right, if there's true, I don't want to see that. I don't want to see that at all. It doesn't make any sense to me. For one thing is, I would let you do it. It's called the bottoms-up method sometimes. I don't know what else somebody else calls it. But if you can explain to me why it works mathematically, I'll let you do it. But the funny thing is, the hardest part of this whole problem is really this step right here. And so why do you need a shortcut from that step? Once you got that, you just put them in a group. Nothing wrong with that. So now some of you guys are just looking at me like I'm crazy, but if you don't divide these by something and do something weird after that, don't worry about it. This is beautiful. If you do, I won't take it. I don't want to see that. Because normally you don't know why it works, and that's not something I'm here to teach you, is methods that you don't even know why they work. Okay. Sure. So what do I do after that?
4x minus 2 plus 3 x minus 2.
Cool. That's a 3 there. Right? 3's really don't work well.
Sorry, just pulling it out. I get it now.
Cool.
Pulled it out.
Yeah, all I did was what we talked about earlier. Those are the same, so I can take it out. If I would have put the 8 second and the 3 first, I would have got the same answer. 4x plus 3 would have been on the inside, and x plus 2 would have been on, x minus 2 would have been on the outside. You guys with me? If I would have just switched these. So those two numbers will work, no matter how you put them in there. But I always put the minus first, so I don't make some negative mistake over there. Are you with me? If I have a choice, I put the negative thing first. If you have no idea what I just said, but you can do this, great, do it. I'm trying to give you a little extra hints.
What did you call that method again you just said?
I call this the Surefire Method. I was born in Georgia, but I didn't learn this in Georgia. I was 5 when I moved away from Georgia. So that's not why it's called Surefire Method. Because I was in Georgia. I actually got taught this method. Actually, when I was tutoring this, somebody showed me this and told me it's called Surefire. It's like, oh, that's cool.
How do you know when to use that method?
Whenever the first number is not
X.
1. So this number was 1. That's why this was easy. That's the only way to split it by squared, xx. How many ways are they split up 4x squared? 4x and x, or 2x and 2x, or x and 4x. That's why there's too much ambiguity. You've got to have a different way to do it.
Can we do that one more time?
Sure. Okay.
Or something similar?
We'll do a different problem. Same idea. Actually, let me see if you guys can see how I do this. Can you do it, Jeff? I don't know. Okay. So to make this problem work, notice I put those first and then I put that second. As I say that, I'm like, does it work? Yes. Okay, that works. So what's the first step here? Yeah, the first number is not a 1. What's the very, very first step, though, really? For any factoring problem. Yeah, because if an 8 came out, that would kick so much ass. I wouldn't have to do this weirdness. But nothing comes out. Shucks. So 8 times 10? Factors of 80 that make 21. And again, add them up to be 21. 18 and 3, but they don't multiply to be 80, right? 16 and 5, there you go. They multiply to be 80. There you are. And then what do you do with those numbers? Good. You split up the middle term. 8x squared plus 16x plus 5x plus 10. So the whole point of Surefire Method is to take a 3-term and make it a 4-term. Now, how many ways can I break 21x up? I can make it 10 and 11. I can make it 20 and 1. I can make it 25 and negative 4. Holy shit, there's an infinite number of ways to do this, but this process tells me the only two numbers that'll make the grouping work. Does that make sense?
Yeah.
4 terms kicks ass because it's grouping. Grouping is relatively easy, but there's only one set of numbers that I can put in there either way, but there's just one set of numbers that makes it work. Those two. And then I take out 8x. Alright, cool. Doesn't matter what order that's in because it's multiplication, right? Yes, ma'am.
Where are you getting the x plus 2? I don't even know where you got that.
What comes out of these two? An 8 and
2.
an x. So if I take an 8x out, I'm left with an x plus 2. So this is a grouping problem, a GCF problem and a GCF problem. That's why it's called grouping. I just group those two different sets together. Okay. Cool. Moving on. So that's one that people normally don't appreciate too much. Another one that people normally don't appreciate too much is coming up here soon. It's not quite here yet. I forgot what number I'm on. Oh well. 7? So here we have, what do we do when so 4 terms grouping, 3 terms either trial and error or surefire. 2 terms could be squares or cubes, right? Squares is what I call a thank God problem, or a thank whatever deity you have in mind, right? If coffee is your deity, then it's a thank coffee problem. The reason I call it that is you can identify it pretty quickly. It's 2 terms. You can only be squares or cubes. Is there any GCF? No. And it's obviously squares because everything is something squared, right? So then you just cut it in half. Minus plus to make the middle term cancel. Yeah. So 2x plus 3 minus 3. So then I get plus 6x minus 6x. No middle term, thank God, because it's not supposed to be a middle term. Yes, sir?
You can't do difference of squares if there's not a minus. It's plus. It's squares plus.
Exactly. You can always do different squares, but you can't do sum of squares. For the same reason I can do this. I can do this because I can make this plus and minus and make the middle term cancel. If I couldn't make these different signs, I couldn't make the middle term cancel. So if I try to factor, I gotta remember Roman numerals. If I try to factor 4x squared plus 9, ain't never gonna work. If I thought it was 2x plus 3, 2x plus 3, no, I'm wrong, because then I get 12x in the middle, right? Minus 3 minus 3, I get negative 12x in the middle. So, prime. As far as we know. We'll find out later it's not actually prime, huh? If I use numbers that aren't real. We will talk about that later this semester. We'll talk about complex numbers, imaginary parts. But right now, you can call a sum of squares prime. Now here's a sum of squares that's not prime. And you're like, you just told me, what the hell? Here's a sum of squares that's not prime. Why is this sum of squares not prime?
Does 10 go with something perfectly? It's a perfect square. 100 is a perfect square.
But that doesn't matter. It's a sum of squares, so I can't factor like that. GCF. Exactly. So what comes out above?
2,
4? 4.
4x, 25.
And that's all you can do because the inside is still a sum of squares, right? So you can factor sum of squares in only one way, GCF, if there is a GCF. Cool. Okay. Yes, ma'am.
So Would you leave that problem the way it is?
Total. Yeah. If there was a minus in the middle, you have to go further. So here, you guys try this one. Let me shut up for a minute. What you got there? So just, there's actually a hint in the way I'm about to write the instructions on this. Yes, ma'am. Maybe. You're right. I know where you're going with that. Yep. I think most of you guys have seen something like this, but if I said factor 18 completely and somebody said 2 times 9, why are they wrong? Because 9 can go further, right? So if I factor this once, I get
4 squared.
good. So 16x to the 4th, break it in half. Plus minus 81, break it in half. And everybody's cool with the fact that when I say break it in half in this context, I mean break it in half multiplicatively, right? Don't say 2 doesn't go in 81. I'm talking about break it into 2 factors. Now, I'm not done. I can't be done. It's good. The second dude is a difference of squares. So the first dude, don't forget about him. He comes for the ride. And the second dude is... Why make so much room? Cool. Okay.
So you break it up even further.
Yes. And the kind of problems where that could happen, notice what was the power to begin with? 4th power. So it was high enough that maybe it could go another step. If it starts off with square, there's only going to be one possible step on that. Okay, maybe. Yes, sir.
So why don't you do the first one like that?
Because it is a... Right? If I try to make the middle term cancel, I have to have a plus and a minus, but that would never make positive 9. Good. So I cannot factor a sum of squares for the exact same reason I can factor a difference of squares. This allows for different signs, which lets the middle terms cancel. You guys see that? Okay, maybe. I don't know. Again, jeez. Some of you guys actually reacted to that, and most of you just saw it. No. All right, so here's the one that people really love to hate, and that's the Q's. But I really don't understand why. How many squares? Out of squares. So let's look at a little side problem. Kind of related to this. How is that related to this, by the way? Not just they have 2 terms. But how many parts of each are there here? 3. And there's 3 x's and 3 2's. Careful, there's only 1 8, but that can be broken into 2 times 2 times 2. You with me?
And that one, there's 2 x's.
There's 2 of each. I love it. So if there's 2 of each, it's easy. There's only, if I put an x there, I've got to put the other x there. If I put 1, 2 there, I've got to put the other 2 there. Right? This is not going to be as easy because there's 3 of everything. There's x times x times x. There's 2 times 2 times 2. Right? We put that 3 down further. Would it be so far?
So then is it broken up into 3?
No, I appreciate that, but no, it's not.
So you're going to have x squared and something.
Yeah.
Good.
Something.
So, let me start us off. We're going to have a little dude
So it would be
and a big dude.
x squared.
Little dude. Big dude. Whenever I see a cube, it's going to be a little dude, big dude. That's where you start, and you start filling them in. A little dude's a little dude. So you can only take 1 of each. Right? So I can put 1x minus 1, 2. You with me so far?
Yeah.
Now, if I put 1x there, I have to put
X squared.
x squared there. If I put 1, 2 there, I have to put 4 there, right? But look what happens. Now, I want you to really, really understand why we have to do that. I get my x, no, Jeff, you've got to put a 2 there. No. I get my x cubed, right? I get my x cubed. I get my minus 8. So why the hell is there more shit? Because I also get minus 2x squared. Do I want that?
No.
No. And I also get freaking 4x. Do I want that?
No.
This is going to get really marked up, by the way. It's going to look like a Sunday football game with good old John Madden back when he was in there. The middle term is going to be what's called the cancellation term, which should kind of make sense. I want the middle term to be what kills these guys. Yeah, so it's going to be, the middle term is always the product of what's in here. And what do you think its sign is going to have to be? Opposite of this guy, because it's the cancellation dude, right? Now let's see. What's x times 2x?
2x squared.
Positive 2x squared. Kills that guy. What's negative 2 times 2x? Minus 4x. Kills that guy, right? So then I'm only left with x cubed minus 8. Because that guy killed the other stuff that I got. I don't know if you guys are with me here or not. Really, it's more complicated because there's more stuff in there. There's 3 things instead of 2. But look, I get x squared minus 4. Minus 2x and plus 2x kill each other. I've only got 2 of everything, so I didn't need as much work. 3 of everything, I need a little more work. Yes?
So I had everything up until you put the 2x in the column. Where did you get it from? I didn't find that.
You always get it from the product of whatever's in the little dude. So watch this. 1 of each. 2 of each. Product in the middle. That's the closest I get to singing a song. Okay. I don't like singing songs. So let me do another one. That's really, impossible to follow. Try another one. I'm teaching you guys Roman numerals at the same time. Let me see. Okay. So if I really attack this the way I should attack any factoring problem, any GCF. Bless you. I know it does, but you gotta force your brain to realize it's actually the exact same damn problem. I want you. It's really weird to say that because you're like, that didn't have to be freaking 27 inches, yeah? Any GCF?
No.
Good. How many terms? 2. 1, 2. Everything in there is made up of 3 of something, right? So then I know it's a cube. It could have been a squares, but the plus would have killed that, right? Even if it was a squares, it couldn't do shit with it. You kind of with me? So the minute I know it's got to be squares or cubes, I know it's a cubes because basically that gives it away, but also everything else can be cut into 3 parts. If I would have put a 65 there, the whole thing would have been dead in the water. I couldn't go anywhere with it. Everything's got to be a green. You with me? So 27y cubed is 3y. 3y is equal? What's 64w cubed?
4w.
You've identified it as a cube, so what do you put down for yourself?
3y.
Good, just humor me. Thank you. Little dude. Big dude. And you start filling it in. What goes in the little dude?
3y.
Good. 1 3y plus 4w. Well, yeah, I was going to try to not mark this up as much. So what's got to go here?
9y squared.
Good. 9y squared. What has to go at the end? 11. So what goes in the middle? Good. Minus, because it's the cancellation, dude. 3y times 4w, 12wy. The product, not the addition. Don't put 3y, 4w. That sounds silly, right? 3 by 4, no, 12 WY is what it is, right? Simplify it. You guys kind of with me?
He said that was probably, where you get the 12 W way?
What's 3Y times 4W? 12 WY. Opposite sign, because what's this dude do? Cancels the stuff I don't want.
Does it matter that you flip? Oh, so you have to flip W and Y, or does it?
It doesn't really matter.
Okay.
Conventionally, I put it in alphabetical order.
Okay.
But if you don't, I'm not going to go,
Okay.
should be in alphabetical order.
I'm
Yes.
just doing it the way that does.
So that middle term is always going to be what's in the middle here? The opposite of this middle?
The middle is always a product of these two. Opposite sign.
Oh.
Cool. So there's a little saying, and I'm not a big fan of sayings in general because you got to see why it makes sense. I don't know if you guys ever heard this saying, same, opposite, always positive. So, right? I'm not a big fan of this because you start to rely too much on this and you kind of forget why it works. But this is a nice little saying to help you remember. This is always the same sign. This is always the opposite of that. This is always positive, period. And one other little thing. The big dude never can be factored unless there's some GCF you forgot. You with me? That you can never factor the big dude. Yeah.
So the product of the first one, so you just 3 times 4 is, right?
Yeah.
And you add that WY?
Yeah, 3Y times 4W is 12WY. You with me?
Well, sure.
There you go.
Can you make the little, like, always, whatever?
Oh, same,
So, yeah, that.
opposite, always positive. Oops. Okay. And again, I don't want to make it seem like you can't use it. You can. Foil, I think I already talked about foil. I don't like foil, but if you like it, great. Because it doesn't go further. The more of these you use to get through math, the less sense other things make, because you kind of forget why this works. I don't know. Probably don't know what the hell I'm saying. He's like, you're a mean person that just doesn't want us to. No. All right.
You said that the big dude cannot be factored.
Exactly.
Because it's in that problem. But if you take that the same number as the big dude and you factor it outside.
What?
Because isn't it that similar to, there's one problem that for me looks like kind of like the same.
Yeah, if that was a 24, you could factor it. It's really weird. This is always half of what it needs to be factorable.
Okay.
And really quick, let me show you. I've never shown anybody else this. So you're my test group here, right? Somebody always tells me that this somehow is like some combination, like 3 pieces to it or something. You guys, right? Somebody was suggesting that. I understand why you might think this is true. Now, this is not true. Don't even write this down. But here's something interesting. Now, watch. You guys see where all it came from? Like, there's 3Y, 3Y, 3 there because there's 3 of them. Right? And there's 4W, 4W, 4W because there's 3 of them. You kind of with me? All right. Don't worry about the minuses. Somebody would have just put pluses there. I understand. But I want to show you something kind of cool. If you foil this out, what do you get? You make that English there.
9y squared.
Minus 12 is minus 24. You with me? Plus 16. See how that's half? If it was 24, you could factor it like this. It's always half of what it needs to be. But this is actually sort of a way to figure this out. You write it down, you foil it out, and then you cut the middle term in half, but I'm never going to teach it that way. I just thought this is an interesting side note. And you guys are all like, don't do that to me, man. I'm just trying to learn the basics, man. But if you didn't, this is totally unnecessary. So don't worry about it. It's just a little side note. Okay. I just thought it was interesting. So that's all the factoring forms. So let's answer the question from the homework in 9-6. It's actually a word problem. So this question says, the base of a triangle is 3 centimeters longer.
You said it was from the online?
Yes. And the height, the area is 27 centimeters squared. find the height and length of the base. So find the height and the base lengths.
Is that 3 or what number is that?
370.
Oh yeah, you can't tell, just assume it's a 3. Pretty much. 3 is my worst number for writing. I'm not good with numbers. So I don't know, on the online homework, each problem should be a little different. It kind of like generates its own. So if you're doing the online homework, you might not get exactly this problem. But
That is the same as the number 47 in that way.
oh, it is?
Yeah. Well, it changed the numbers. Like
There you go.
Instead of 2 centimeters, it's 2 feet. But it's
24 square feet. Yeah, exactly. Same kind of problem.
Yeah.
I love it. So a really good idea here is to draw this thing out for yourself. And the base is 3 centimeters longer than the height. So what are the players involved? The base and the height. Which one is just X? Or whatever letter you want to use. Yeah, why is the height just X?
Because we don't know what it is.
Because the base is something to do with it. So I've got to know that that's X first, and now what's the base?
X plus 3.
The gas? Now here's where you got to be really careful. If I label this, here's the height. Height's always perpendicular to the base. So the height is X and the base is X plus 3. What's the area of a triangle? What's the formula for the area?
1/2 base times 8.
Good. Area is 1/2 base times height. Because if I have a quadrilateral, a triangle is half of it. So it's half the base times the height. So the area, they tell me, is 27. 1/2. And what's the base?
X plus 3.
X plus 3.
And what's the height?
X.
Beautiful. So how do you solve this problem?
You multiply 1/2 across?
Say again?
You multiply 1/2 across? No.
I would kill the 1/2. How do you kill the 1/2? Multiply both sides by 2. So get that 1/2 out of there. Let me do a little side note here. A little side note. Can somebody tell me what the answers are to this?
X minus 1 equals 0.
Good. The only way two numbers can multiply to be 0 is if the first one is 0 or the second one is 0. You put any other freaking number there and the whole thing goes to crap. Two numbers multiply to be 4. Well, the first one could be 4 and the second one could be 1. Or the first one could be 8 and the second one could be 1/2. You kind of with me? There's an infinite number of things to give you, but if they multiply to be 0, one of them's got to be 0. So the problem with this currently is it's equal to freaking 54. So how do I correct for that? Good. Foil this out, and then suck the 54 over, right? So you get very strange ways of saying things with 2x. And then subtract 54 over, right? Make that side 0, because this only works if it equals to 0. Okay. So I get x squared plus 3x minus 54 equals 0. And now you see why it's in this section. Then you factor it. Coolness.
96.
Okay, so you get x 9, 6. Which one's what?
X plus 9 is 1.
Good. Big one's positive.
Equals 0.
X equals negative 9, positive 6. Considering this problem is about lengths of a triangle, I can throw out negative 9. That's a freaky thing. So the height is 6 what? Okay. And the base? 9 centimeters. Notice how math, if I would have said it was negative 9, this would have been negative 9 plus 3, negative 6. Don't they still multiply to be 54? Negative 6 times negative 9 is 54, right? You kind of with me? 54. So math gives us the negative answers. We as the humans have to throw them out and say, I can't make a negative length of something. What is that? Right? What material is that? Yes?
I have a question on one of the papers.
Okay, sure. Is that cool? So that's like the problem number 47 in 9.6.
Before you erase that, please go back over and look up 0. Where I see you did the minus 54 equals the x squared plus 3x.
Yeah, so I did this minus 54 to both sides. So I get 54 minus 54 is 0. I just put it on that side because it doesn't really matter which side it's on.
Alright, that's fine.
So I just put it on that side.
Confused me.
Cool. So I can always flip an equation around if I want to. Alright.
Thank you. It's problem 39 from 9.6.
39?
Yeah.
Oh, okay, yeah. Everybody, a lot of people when they see this kind of problem, they try to factor like it's a trinomial. It's not.
Don't you subtract 0?
Say again?
Don't you subtract 0?
Well, it's already 0, so I'd have to subtracting 0 wouldn't do anything, right? If this was a 10, I'd have to subtract 10. It's already 0, so what can I do to this? GCF, exactly. Everybody forgets GCF exists. You start to try to do this like this, and it's never going to work like that. What comes out of both?
X minus 5.
So then either
2x
squared equals
0
or
x minus 5 equals 0. I got stuck with the 2x squared equals 0.
understood. You can do this for yourself. Watch, you ready? Isn't this 2x times x? So then 2x equals 0, or x equals 0, or x equals 5. And this gives me the same answer as that, right? So if x squared equals 0, x itself must be 0. That's the only thing I can square to get 0. So you can do that, or you could divide by 2 and then take a square root. Whatever way you want to do that. Cool. Okay. Wow, holy crap. Jeez. I guess we're not going to get to chapter 2. Man. Alright, so just real quick, Thursday we'll get as much out of 10 and 11 done as we can. Let's see how much that is. And then the test will cover however much we get through, because the test is a week from this Thursday, yeah.
Already?
Dude! Yeah. Oh yeah, okay. And then... Oh yeah. Minus 1 exactly.
Yeah.
Okay, good.
And then I just didn't see that. I just didn't read the last one. So.
Yeah, H of 4. Oh, so you put everything in there, yeah. Okay, okay, gotcha. Thank you. Yeah. Yeah, cool. Plus y divided by a, good. And then you redo those for me too, because that'll change those.
Oh.
I didn't take points out because you did it based off of that. That's where you made your mistake. But now, what are they going to look like?
So now.
Hey, my test will make up for that?
Say what?
My test? The test will make up for
We'll do what I said,
Yeah.
and then the test will make up for it.
You know, I forgot to even give you the pages of all my notes. I had the answers on some of them, I just didn't. I noticed that today when I was
Don't
cleaning
mind.
stuff up.
And I figure you must have had them somewhere. I'm like, gosh, all right.
Yeah.
But yeah, corrections and then do better on the test. Cool.
I have a question with this. So you take minors. We just like one way to make sure I get the. Should I not put it on it?
Yeah, because if I say use a table to graph it, then I want to see this. If I say find the slope, I don't want to see this. I want
Because
you.
if I take this out, it would still be the same.
Exactly. So
Okay.
you could do that
Would that be a problem?
and never show me you did it.
Okay, Because in my problems, in the work problems, I did the same. Should I take it out?
Yes. If they say graph it using the slope and the y-intercept, you should not need a table at all. You plot the y-intercept and you count the slope, you don't need a table.
And if they say just graph it, can I do
If they say just graph it, you can do whatever the hell way you want to. Except, do the graphing calculator. Yeah. Cool.
Yeah, what's up, man? Just want to ask you. I got a 6 and I don't want to quit. What's the questions and everything? What would I go up to?